everybody. Are y'all ready to talk more about minerals? Today's going to be kind of cool. I mean, it's a little bit boring because we're taking notes, but cool all at the same time because I have a whole bunch of mineral samples that I'm going to show you and that we're going to talk about. So, first things first, let's look at this note page right here. If you have it handy, the vocabulary that we talked about yesterday will help you with this today. I will upload some copies of this into our files tab. The vocab will also be up there. If you have a printer, you can print it out. If not, pause the video, make you a note page, something like this, and we're going to talk about minerals. So first things first, what are minerals? And if you remember from yesterday, minerals are an inorganic solid made in nature of a specific chemical formula with a 3D structure. So that's a mouthful. We're going to break it down though. But first, let's write right here, an inorganic solid made in nature of a specific chemical formula with a 3D structure. Okay, it's kind of a mouthful. Well, let's talk about it. So it says a bunch of characteristics up here, but let's kind of break it down a little bit. So what are the characteristics of a mineral? So over here it says they're made in nature. So we're going to write that they are naturally occurring. They're not man-made. I'll underline not right there. So people try to make like imitation stuff, imitation minerals. I don't know if you've heard of these lights. Come on, guys. There we go. They've tried to make diamonds. Instead of digging them out of the ground, they have been trying to find a way to make them in a lab, which, I mean, are they diamonds? Technically, but they're man-made diamonds, which is a little bit different than a natural occurring mineral. Next, we've got this word right here, this inorganic. It's one of our vocab words, and inorganic just means that it doesn't come from living things. So I'm going to put inorganic right there and then do not come from living things. So living things would be plants and animals. Okay, so any kind of anything back in the day that passed away, turned into mulch, got pressed together, that is not what a mineral is. Minerals are not plants and animals. So I'll say not from plants or animals. Not. Okay. Next, we've got right here, it's a solid. Okay, so you're not going to find a liquid mineral. Liquid minerals are not a thing. They're all solids. Okay. Over here, we've got specific chemical formula. So we're going to write down a definite chemical composition. That just means that it's made of specific things. So depending on the type of mineral that you have, so this is quartz right here, and this is sulfur, okay? These two minerals are quartz and sulfur. There is specific atoms in the chemical formula of this quartz that make it quartz. It is not the same thing that makes up this sulfur. Does that make sense? It's two definite chemical compositions. They have their specific chemical formulas. They're made of their own thing. Does that make sense? Okay. Last but not least, across here they have a 3D structure. So a 3D structure, if you look at our piece of paper here, this is two-dimensional. It doesn't have a 3D structure. But my feldspar right here, this has a three-dimensional structure. There is a length, a width, a height. It has a volume and a mass. This has a 3D structure. So we're going to write that down. Okay. I've got some examples we can talk about. So right here, this one is called talc. And talc is the softest mineral that we have. And talc is so soft that I can scratch it with my fingernail. I don't know if you can see that very well. Let me find a nice soft spot. Oh, there you go. Can you see that? Not really. Focus. There we go. All right, I'm going to scratch my fingernail across this. You see that powder? That is not my fingernail. That is this talc. So talc is really, really soft. That's a good example of a mineral. You might have heard of talc in maybe powders or like baby powder, stuff like that, that might have talc in it. And this is talc. So we're going to write down talc right here. That's a good example. Okay. So opposite end of the spectrum, talc is super duper soft. A diamond is a mineral, but that is super, super hard. A diamond is one of the hardest minerals on Earth. I mean, it's hard, hard, hard. So diamond, unfortunately for all of us, I don't have a diamond to show you. But that's okay, because I'm sure you've seen them on TV or here or there. Another good example is topaz. Have you ever heard of topaz? They make jewelry out of it. We've got quartz, and I have 3 different types of quartz that I can show you. That is just a white colored quartz. This one here is rose quartz. It's kind of hard to see the difference right there. Let me see if I can. This one, sitting here looking at it for me, looks pink. And this one here is white. Well, here's another example of quartz. Now that's the outside, but this is the inside. Have you ever heard of, oh, what are they called? The rocks, you can go get them from like a creek bed, and they look just like a rock on the outside. And when you break them open, you get this super cool like stuff on the inside. Well, those are not rocks. Those are minerals. So these are 3 different examples of quartz. They are all the same, even though they're all 3 different colors. Kind of cool, right? We're going to bring these back out when we do the next note page about how to test these minerals. Let's see. Ooh, I have another pretty one here. I showed you this a minute ago. This is a pretty green one. This is called feldspar. I love that pretty green that it is. And it can come in all different shades of green, but this one was just the one that I grabbed. So feldspar. I also have a couple other ones here that I can show you. This one right here is called pyrite, and you may have heard of it called fool's gold. So this is a mineral. This is not real gold, but this is fool's gold. It's a mineral called pyrite. It's kind of pretty, huh? We have, oh, this one right here. We live in a town named after this mineral right here. This is sulfur. I don't know if you've ever driven down the highway whenever it kind of smells funny outside, but if I pick this up, I can smell it. And sulfur has a very distinct odor and a very distinct color. So this bright yellow, you're almost always going to know. If you have a bright yellow mineral like this, you're going to have sulfur. If you want to test it a different way and make sure, you can give it a smell. And you can sure smell sulfur. I kind of wish you guys were here where you could smell it, because it's kind of cool. This one right here is kind of cool. Look at how pretty that broke off. That's cleavage and fracture is a thing, but we're not really going to talk about it. But they didn't sand the edges on this mineral. They just broke it, and it broke along these definite lines like this. I think it's kind of cool. This one is actually called halite. And if I were to, I'm not going to because little hands have touched this a million times, but if I was to lick this, it would taste like salt. Halite has a very distinct flavor. So this one tastes just like salt, and you can see it's almost clear. And even as thick as it is, it's still, you can see my fingers very clearly through it. I think that's kind of cool. Let's see, what else do I have here? Oh, this one here is really pretty. I'm going to shine the light on it because I want you guys to see how it reflects the light. You see how kind of shiny that is right there? This one right here is called a hornblende. Oh, there you got it. It's pretty, huh? I love how reflective that is. Well, we're going to pull all these back out in a minute and talk about the different properties of them. Let's see, this one right here. This is called magnetite, and this one is kind of cool. Let me pause for just a minute. Somebody's trying to come in my room. So this mineral right here, it's called magnetite, and it's actually magnetic. So if I had a magnet here, I could hold it up to it, and you could see how it would be attracted to a magnet. Unfortunately, I don't have a magnet right now, but I'll try to get one and show you guys in the next couple of days. Let's see here. I've got one more that I think is kind of cool. This one is called hematite, and it's very powdery. Like, let me show you real quick on this paper. I'm drawn with it on the paper. It's so, it's just kind of powdery. It's very earthy looking, dull. It's not shiny at all. And you can see how it's just kind of running off on my fingers. My fingers are kind of messy right now. It's kind of cool. Anyway, so that's the samples that I had to talk about today. And we are going to figure out how these minerals are formed. I went and washed my hands real quick to get all that powdery stuff off of them from that mineral. So let's talk about how these different minerals are formed, and they're formed by crystallization. So I'm going to write crystallization right here. They're formed by crystallization of minerals that were dissolved in water, and whenever they cooled, they kind of stuck together and formed them. So you might see, let me scoot that over so you can see it. Crystallization of minerals dissolved in water. So you might see this a bunch like in caves or in lakes or riverbeds, any place like that that has bodies of water. If there's the chemical formula, the chemical composition, stuff needed to make the different minerals, they'll kind of dissolve and kind of crystallize together. Have you ever made rock candy from sugar water? So if you get water really, really hot and dissolve as much sugar as you can to make a solution, just barely have little pieces of sugar on the bottom. And then you put like a stick in there or a string, it'll crystallize to that string or to your stick, the sugar will, and you'll form crystals. This is the same idea. Minerals being dissolved in water kind of do the same thing. They crystallize as the water cools. Now there's one other way that they can form, and that's by crystallization of magma or lava. Do you know the difference between magma and lava? All it means is one is inside the earth and the other one came out of the ground. So it's molten rock from our asthenosphere, and it comes to the surface, and if it's at the surface, it cools outside, and those crystals form in the in the lava as it cools outside the ground, or they form on the magma as it cools inside. Does that make sense? They're the same thing. It's molten rock. One just cools on the inside and one cools on the outside. So I kind of hope you enjoyed checking out my minerals. Man, it'd be so cool if you were here in class, because then I'm going to have them out sitting on the desks and everything. If you have minerals at home or rocks at home and you want to tell me about them, shoot me a picture. I'll see what I can do about being able to do like, I don't know, maybe a flip grid or something. We'll figure that out in the next days to come. But I love rocks and I love minerals. And this is one of my favorite units ever because earth science is my jam and rocks are all about the earth. So y'all have a wonderful day and we will see you tomorrow. Make sure you answer the questions below.